Good morning. Our topic is the assignment method. In assignment method, the problem here is concerned with allocating the jobs to each of the workers for minimum cost. There are three main steps to follow in solving an assignment problem. First is subtract the smallest cost from each entry in each row. If each zero can now be assigned one-to-one correspondence with the workers, an optimal solution is reached. If it cannot, go on step 2. Subtract the smallest cost in each column. If the zero entries can now be distributed one-to-one correspondence with the workers, an optimal solution is reached. If it cannot, go on step 3. Cover the zero entries by vertical or horizontal lines using the least number of lines possible. This can be done by covering first the row or the column having the most zeros. Subtract the smallest uncovered cost, but add it to the entry found at the intersection of the lines. In an assignment is already possible, or if an assignment is already possible, an optimal solution is reached. If not, then repeat again step 3. An assignment is optimum if the number of lines used is equal to the number of rows or the number of columns. Let us try this example. 4 engineers are to work on 4 projects of a PSB construction company. The problem here is to decide which engineer should be assigned to each project. Each engineer charges different fees on each project due to distances of the projects and the complexity of work. The cost of assigning particular engineers to particular projects are as follows. So the objective here is to find the least cost of assignment. Okay, so for the first table, let's say this is 11, this is 6, we have 4, this is in thousands, we have here 11, then we have here for the second column 8, 5, 8, 10. Then we have 10, 3, 10, 5. Then we have 7, 8, 9, and 7. Again, this is in thousands. Okay? So again, for the first step, we need to subtract the smallest value from the entries in the row. Okay? For the first row, we have there 7. So we have here 11 minus 7, we have 4. Then 8 minus 7, we have 1. 10 minus 7, we have 3. And then 7 minus 7 is 0. Okay? Next, the smallest value is 3. Okay, so we have for the second row, we have 6 minus 3 is 3. 5 minus 3 is 2. 3 minus 3 is 0. 8 minus 3 is 5. Okay, next we have for the third row, we have 4. The smallest value is 4. So we have 4 minus 4 is 0. 8 minus 4 is 4. 10 minus 4 is 6. 9 minus 4 is 5. Then for the fourth row, we have there 5. The smallest value is 5. So 11 minus 5 is 6. 10 minus 5 is 5. 5 minus 5 is 0. 7 minus 5 is 2. Okay. So here we still have a column that doesn't have zeros. Okay. Or doesn't have 0. So we move on to the next step. Okay. Okay. So for the next step, okay, our treatment will be by column. Okay, so we have here the smallest is already 0. Okay, so we have there, we can just copy 4, 3, 0, and 6. Okay, for the next column, for B column, we have there, the smallest value is, okay, so you can see we have there 1. Okay, so we have 1 minus 1 is 0. 2 minus 1 is 1. 4 minus 1 is 3. Then we have 5 minus 1 is, we have 4. Okay. Then for the third one, we have there 2 zeros. So we can just copy. We have 3, 0, 6, and 0. Okay? Then for the fourth, we have there, okay, we have 0, 5, 5, and 2. Okay? So let us cross out the most number of zeros. So we have here 1, then 2, and then 3. Okay? So it's not yet the optimum solution. Okay? So we need to find the smallest value in the uncovered entries. We have there 1. So we need to subtract 1 from all the uncovered entries. So here we have 1 minus 1 is 0. 3 minus 1 is 2. 4 minus 1 is 3. Then we have 5 minus 1 is 4. Then 5 minus 1 is 4. Then 2 minus 1 is 1. And then for the intersection, we need to add the value that we have subtracted from the uncovered. So that's 1. So this will be 4 plus 1, we have 5. Then 3 plus 1, we have 4. Okay, then we can just copy all the covered values. We have here 0. We have here 0, 0, 6, 0. Then we have 3, then 0, and then 6. So again, we cover all the most number of zeros. It's either column or row. We have here 1, okay, then we have 2, then we have 3, and then of course this one we have 4. Okay, so that means since this is a 4x4 table and we have 4 lines, okay, so it means that we have arrived at our optimum solution. Okay, so we can now assign. Okay, so we have here for engineer 1, okay, engineer 1, 2, 3, and 4. For the projects, okay, we have, okay, so for engineer 4, we need to prioritize those the rows with only 1 0. Okay, so we have engineer 4, okay, that is C. Okay, project C. Okay, so what is project C, or how much is project C? We have 5,000. So this is C, that is 5,000. For so we already assigned C, so we remove this. Okay, the next, okay, we have engineer 2. Okay, so we have here B. So B is how much? 5,000. Okay, the next is, okay, we cannot assign this because we assigned B already for engineer 2. Okay, so we have here D. Okay, so D for engineer 1, project D. Okay, how much is project D? 7,000. Okay, then for 3, we have A. Okay, so project A. A is how much? 4,000. Okay, so our total cost is how much? We have 21,000. Okay, so this is our total cost. Okay, so another problem. We have here, engineer Moraza has to assign 4 teams to work on 4 projects. The costs charged by each team are as follows. Costs are in thousands of pesos, so determine the least cost of assignment. Okay, so again, we start with the rows. Okay, so we have here, okay, 15, 18, 21, 17, 18, 17, 20, 15, 20, 14, 13, 18, 16, 20, 15, and 19. Again, this is in thousands. So our first treatment is by row. Okay? So for the first row, for the first team, our smallest value is 15. Okay, so 15 minus 15 is 0. 18 minus 15 is 3. 20 minus 15 is 5. 16 minus 15 is 1. For the second row, for team 2, we have our smallest value is 14. So we have 18 minus 14 is 4, 17 minus 14 is 3, 14 minus 14 is 0, 20 minus 14 is 6. Okay? Then for the third row, we have there team 3. Our smallest value is 13. So we have there 21 minus 13 is 8. Then we have there 20 minus 13 is 7. 13 minus 13 is 0. 15 minus 13 is 2. Okay, then next is we have there for the fourth row or team 4, we have the smallest value is 15. So 17 minus 15 is 2. 15 minus 15 is 0. 18 minus 17 minus 15 is 3. Okay? Then 19 minus 15 is 4. Okay, so we have here for the first column, we already have there 0. For the second column, we have already 0. For the third column, we have 2 zeros. For the fourth column, we don't have 0. Okay, so this is not our optimum solution. Okay, so we need to develop again another table. Okay, so for the third table, we have there, okay, so we have 0. We can just copy this one since there's already a 0. 0, 4, 8, and 2. For the second column, we have there 3, 3, 7, and 0. For the third column, we have there 5, 0, 0, 3. And for the fourth column, our smallest value is, okay, we have there 1. So we need to subtract 1 from the values in the fourth column. So we have here 1 minus 1 is 0. 6 minus 1 is 5. 2 minus 1 is 1. 4 minus 1 is, we have 3. Okay, so then again, we need to cross out the most number of zeros. It can be by column or by row. So here we have, okay, let's choose this one since there are 2 zeros. We can choose this one since, again, there are 2 zeros. And of course, we need to cross this out since there is a 0. Okay, so since this is a 4 by 4 table again, we need to have 4 lines. Okay, we need to draw 4 lines. So this is not our optimum solution. Okay, so again, we need to find the smallest number or smallest value in our uncovered entries. So we have there 1. Then we need to subtract 1 from the uncovered entries. So we have here 1 minus, 4 minus 1 is 3. 8 minus 1 is 7. Then we have 3 minus 1 is 2. Then 7 minus 1 is 6. And then 5 minus 1 is 4. And then, of course, 1 minus 1 is 0. Okay? Then we need to add that value, the smallest value that we subtracted from the uncovered entries to the intersection. Okay, the values in the intersection. We have there 5 plus 1, we have 6. Then 3 plus 1, we have 4. And then we can just copy all the uncovered, all the covered values. We have 0, 3, 0. We have 0, 0. We have 2, 0, and 3. Okay, then again, we need to draw our lines. We have here, okay, 1, 2. Then we have 3. And then, of course, this one, 4. Okay, so we have there 4 lines. Okay, we can now assign our projects. Okay, so we have here team 1, 2, 3, and 4. Okay, so for this one, we have, okay, choose the row that has 1 0 only. That's row 4 or team 4. We have there B. Okay, so assign B to project B to team 4. And then we have, okay, team row 2 or team 2. We have there C. Okay, then for okay, so we already assigned C to team 2. We cannot assign it to team 3. So team 3 has D. Okay, so we have it here. Team 3 is D. So since D is already assigned to team 3, we cannot assign it to team 1. So team 1 has project A. Yeah, so we have there project A. So how much? So for A, we have there 15,000. Okay. Then for Team 2, Project C is, we have 14,000. And then Team 3, we have D, we have 15,000. And fourth, or Team 4, we have there B, that's 15,000. Okay. So we have there, okay, 15,000 plus 14,000 plus 15,000 plus 15,000 is, we have there 59,000. This is our total cost. Okay, so that's it. Thank you.